Okay, good morning everyone. So we are here at the Hong Kong Web3 Festival, and I'm standing in front of you with a talk about Web5. Reasonably speaking, I am sure some of you are wondering what Web5 means, or why we would need another term when we already have crypto and blockchain and Web3. But the term Web5 describes the idea of a synergistic relationship between Web 2 and Web 3. It was coined by Twitter founder Jack Dorsey 3 years ago, and it turns out to be a pretty good way of looking at blockchains. While everything around us is called Web 3, the way these systems are functioning is significantly different. And Web 5 gives us this way to make sense of the relationship between Web 2 and Web 3 all around us. We're familiar with Web 2. This is this infrastructure that runs all of the sites, apps, and services that form the modern internet. These applications are operated by companies. We connect to their servers, and the user experience has been refined over years. It's pretty good, or at least familiar to all of us. The idea of Web3 came along about 10 years ago, and according to the Ethereum Foundation's website, the idea was to free people of the handful of centralized entities that held a stronghold on the World Wide Web. Web3 was intended to replace these companies with decentralized systems that would be built, owned, and operated by users on blockchains. We really need to look at the differences between Web 2 and Web 3. So public blockchains come to consensus across the globe, across many different nodes, and this produces universal access and censorship resistance. It's a resource-intensive process. Web 2 systems aren't burdened by this kind of process, but they also aren't censorship resistant. And it's natural that these systems would feel different to a user and have different costs to use. There's always a notion of trade-off when we're talking about Web 2 and Web 3. However, if we allow the goals of these very different systems to become mixed, we end up in this endless process of compromise, of decentralization, and censorship resistant. And this is something that is clear from even the most basic Web3 interactions. So when I connect my wallet to MetaMask, there's a connects through a service, through like Infura, something like that, to an Ethereum node. The problem is the majority of these nodes are running on cloud providers like the kind of thing that the Web3 pioneers set out to replace. We've got these companies in the middle still. This is not user-owned or operated, and there could be all sorts of companies and Web 2 infrastructure between a user signing a transaction and that transaction actually making it to the blockchain. And much of the industry's infrastructure is running like this. There's probably a prominent company out there that's paying the bills, and we can see this process of compromise for a Web 2 experience playing out on the innovation side of things as well. For a long time, we were told we needed more block space, and we saw lots of chains and roll-ups launch, and now we have all sorts of different chains, and there's fragmentation across the industry. There's work to abstract away all of these chains from users, and even to create new kinds of systems with new security assumptions that can do transactions across chains. Some thought leaders will tell you that we're headed to a world of millions of blockchains, which would be a lot of infrastructure spending. This quote of $13 million a year to operate a blockchain. And we see that new assets are created to structure something like a business model for a blockchain, but this seems to cause a lot of problems. The infrastructure is dominated by speculation, and we have intense competition. And all of this began just to produce more block space to deliver a Web 2-like experience. And the most surprising thing out of all of this innovation is the rise of what most people would say is the most limited blockchain, Bitcoin. Its market dominance has been steadily rising for the last 2 years, and its developer community is as strong as it's ever been. And this process of compromise in Web3 has led to the exact kind of system that the Web3 pioneers set out to replace. Base is operated by a large publicly traded company and runs Ethereum on traditional centralized web infrastructure. There's a clear trend here, sacrificing censorship resistance and decentralization to deliver a Web 2-like experience. And we've seen in many cases, users don't care. They just want to transact easily, and we should support that. The unfortunate thing for a project, say, like Solana, is that they're competing directly with Base on things like user experience, transaction cost, confirmation time, liquidity, and their Base is not subject to the kind of consensus constraints that, say, Solana would be. But if we step back and think about things, Base is clearly a Web 2 system, but it is using Web 3 technologies. And we can say, if we get creative, that Base is forging a new path that brings public auditability and openness to a privately owned system. And maybe the opportunity is how we connect together the private blockchains and public blockchains. Making Web3 cheaper is just one way of combining Web 2 and Web3 technologies. We can take another example here, Nostr, where users are distributing messages over Web 2 servers. It still kind of has a Web 3 thing to it because these relays that users connect to have distributing these messages. And if a user gets censored by one relay, they can always just connect to another. BitTorrent is another example. Users will find the torrent information on Web 2 servers, and then they will find their peers in a Web 3 peer-to-peer like network to actually get their files. And if we keep building this way, we can actually start to deliver the kind of Web 3 kind of things that we would think about, like verifiability and censorship resistance, in a much more familiar Web 2-like environment. Bitcoin, for example. The proof of work can be easily checked by any of us. We can use our phones, we can use a web browser, desktop computer, and with the proof of work alone, we have what's needed to reach the Bitcoin network. And in Bitcoin, there's also no need to sync all of the blocks. Users can just sync blocks with transactions that are relevant to them. And with this information, they gather everything they need to access the network and create transactions. So this is something censorship resistant. There's no one standing in the middle between a user and what they want their transaction on-chain to do. And Bitcoin's UTXO model and proof of work are very important to building this kind of system. We wrote this article that lays out a thesis that says if you choose proof of stake or the account model in your blockchain, you will always have some barriers between users and what they want to do. There'll always be some kind of Web 2 system in the middle. Let's look at scaling. So we know that in order to scale a system like this, we can just make bigger blocks and add more servers. But if we want to scale on the other side of things, we need to get some more tricks from Bitcoin to scale off-chain. And in Bitcoin, users can collaborate to create transactions that are cryptographically binding, but also replaceable. And this is the backbone of something like Lightning. And it turns out that doing things this way has some very interesting properties. If we think about a blockchain is limited by the speed of a single node because all of the nodes need to verify a block before they can move on to the next. But in a channel network like Lightning, they're not subject to this kind of thing. They don't have the congestion problems or fee spikes that we're used to with blockchains because each of these nodes can independently route payments. And this means transactions can be instant, but also much more powerful. Tether introduced USDT to the network recently, and I'm sure everyone can see that there's a clear case for stablecoins. It's apparent that Lightning is moving beyond being a single Bitcoin payment network, but there's more to it. The flexibility of this off-chain environment allows us to do things like swaps of stablecoins inside of a single transaction. We can have a user pay in USDT and a user on the other end of the transaction receive euros. And an important thing here is that the intermediary routing nodes only see Bitcoin. And this kind of system is going to be crucial when we get an environment with lots of stablecoins. So you can imagine a day where we have thousands of different issuers of, say, US dollars. And if we were to manage that in an on-chain environment, we would have an insane amount of pairs. But if these are just off-chain swaps, it all works pretty well. And it turns out that this kind of swap thing is really only the start. You can also cross chains in this way. And you have these gateway nodes that can, in the same way that swaps work, move things between chains. And we're already seeing building in this direction. There's the Fiber Payment Channel Network on CKB, which supports Lightning, Bitcoin, RGB++, and also the Perun framework, which supports 9 different blockchains, including private blockchains. And we have this seamless connection across chains inside channels that starts to look like the network of networks that thus far we haven't been able to create in our industry. And this moves away from the idea of competition. I really like this sentiment from Umi, from Breeze, that Lightning can be the language of blockchain liquidity. And the thing about building on this other side of this Web5 symbol here is that it is completely novel. Even Satoshi imagined things being built kind of like Base, but in a much more verifiable way, that miners would be these massive farms and users would just get their certainty from checking proof of work. And this is where CKB comes in. It was designed from the start to be this off-chain verification and commitment layer, and it follows in Bitcoin's footsteps and thus far offers similar properties. So in an ocean of Web3 where it feels like every blockchain kind of does the same thing, CKB can be used to do all sorts of novel things. For example, testing out the latest Bitcoin soft fork proposals or some Lightning improvements. And these really are simple things as far as CKB is concerned. This side of things is incredibly exciting. And I know that there is a ton of potential to be found, just waiting for those pioneers. And I invite all of you to join us on this Web5 journey. The two sides of Web5 could not be more different. But usually in technology, we do see differing visions for how things can come together. 50 years ago, people thought computers might be just these cold calculating machines, while others thought they would be something much more human. It turns out, in the end, both of these visions are kind of right. And there's no reason to think that Web3, Web5 will be any different. For those Web5 pioneers out there, we should feel comfortable inventing our own science to move through this landscape. It's very common in our industry. And I think Web5 is rooted in some really important acknowledgments of the role of Web2 amidst this Web3 environment. Thanks to Jack Dorsey for opening this can of worms that we are now stepping through. Thanks to Jen Shi for reasoning a lot of this foundational knowledge. And to Hongzhou Chen for this incredible meme and also helping to make sense of these things. And thank you all for coming, and let's build Web5.